Hello and welcome to Education at SSBJ Online Video Tutorials. As usual, we are going to focus on few questions of chapter motion of class 9th CBSE. Right? And through this question, in this tutorial, we are going to learn meaning of acceleration and how is it related to velocity, and then how the velocity is different from the speed. Now to start with, please remember, to understand acceleration we have to understand velocity, right? And to understand velocity we need to know the meaning of speed and difference between a speed and velocity. And therefore, in this video tutorial, we shall quickly recapitulate the previous video which is on speed and velocity, so that we can connect that information to understand meaning of acceleration. Right? So let us start with the same example of a car which is moving in a direction of east and then it turns towards north for some kilometers. Let us draw the motion of this car using lines, and this is what 4-kilometer distance it has traveled towards east, and then it takes turn towards north and covers 3-kilometer distance. And suppose it takes time from moving from A to B 0.2 hours, then how do we calculate speed? We have already studied that a speed is distance covered in unit time, right? So the formula for speed is total distance covered divided by total time. So quickly we can go for total distance covered is 7 kilometers divided by 0.2 hour, which is equal to 35 km per hour. So this calculation you can pause it and try to understand, or go through the previous video. We have explained and in detail understood the concept of speed. And we have also seen that suppose in place of distance covered divided by time, if we replace this distance covered by displacement divided by time, then we are going to find out what is displacement. And suppose if this A and this is the B are the initial and final positions respectively of this moving car, then the shortest distance between A and B will be the hypotenuse of this triangle, rectangle triangle, and that is what the displacement, right? And how will you find out that displacement? AC. So AC is the displacement. We can use a Pythagoras theorem. Again, I am quickly moving with Pythagoras theorem here, and so substitute all the values. 4 square plus 3 square will give you 16 plus 9, which is equal to 25. So AC will be equal to 5 kilometers. And suppose if you replace this total displacement by 5 kilometer divided by total time, that is 0.2, right? So that is going to be, 5 kilometer divided by 0.2, which is equal to 25 kilometer per hour. And what do you call this concept? This is the value for velocity. Okay, and what is velocity? Formula: velocity is the displacement divided by total time, and by definition it is distance traveled by a body per unit time, but very important is in a given direction. If you cut down your definition till here, then it's a speed. Now for the speed, if you connect a direction, then it's a velocity. Please remember this, okay? Because we have taken a displacement, and displacement is nothing but the distance which has a particular direction. Okay, so if you divide displacement divided by total time taken, then you get a velocity, right? So direction is very important, right? So again, let me remind you, distance traveled by it per unit time in a given direction, that is this distance, is nothing but displacement. So what we have studied in the previous tutorial is the difference between a speed and a velocity. Okay, so though they are expressed in meter per second in SI unit, both are expressed in meter per second, but they are different. It's a distance traveled in unit time, whereas the velocity is displacement per unit time, that is distance traveled in a given direction, right? And second second difference, we have seen that if the body moves in a straight line and comes back, then the displacement becomes 0, and therefore velocity also will become a 0. But there is no way that a distance becomes a 0. If a distance becomes a 0, that means A and B points are at one point only. That means the body is not moving, and since the body doesn't move, it has no speed. Therefore speed cannot become a 0, where velocity can become a 0. And since velocity has a direction, this is a vector quantity. So we had seen few differences of velocity and speed. Please pause this slide and go through the differences. Now, with the information which we have right now, that is the meaning of velocity and speed, we will move towards another situation, right? We shall take the same example where the car is moving in a particular direction, where at the bottom I am going to show a time, right? And whereas on the top I am going to show speed. Please remember speed, and speed I am using the unit meter per second. Okay, so at first second the speed of the car was 2 meter per second, and then at the second second it was again 2 meter per second, third second 2 meter per second, fourth second 2 meter per second, and so on. Fifth second also it's a 2 meter per second, right? And what does it mean? It means that the speed doesn't change. The odometer of the car, odometer, you know, the odometer you will find on every bike or a car, where a needle will show you its speed. So speed is 2 meter per second throughout this journey from here to here, right? So what kind of speed we call it as? Since the speed is constant, we call this as uniform speed, right? But what about velocity, right? And what is a uniform velocity then? Can we call this as uniform velocity? Yes, we can very well call this as uniform velocity. Since uniform speed is constant speed, the uniform velocity is nothing but constant velocity. Now here I am equating speed with velocity. Both are same here. And why they are same? Because vehicle is moving in a straight line. There is no change in directions. Since there is no change in direction, in this case speed as well as velocity both are same. Therefore you can call this as a uniform velocity, and you can take this 2 meter per second as velocity also, though we have represented it as a speed because it has got a single direction. Therefore a body has a uniform velocity if it travels in a straight line and moves equal distance in equal intervals of a time. Look at this. If it moves equal distance in equal intervals of time, so what does it mean? It keeps its speed constant. If it moves equal distance in equal intervals of time, it is moving in a constant speed. Since it is moving in a straight line, this has a uniform velocity. Okay. Now, from here, suppose if a car turns and start moving, and again for every second, let's say this is 6 seconds, 7 seconds, 8 seconds, 9 seconds, it is moving in same speed, right? So let us see. So please understand that this is the first second, second second, third second, fourth and fifth, and this is continuation, 6th, 7th, 8th and 9th second. If in this case, now you can see that the speed is constant. Look at this, because speed has no direction. Speed has no direction. But if you talk about velocity, velocity is changing. Please remember, velocity has a direction as well as magnitude. Any physical quantity which has a direction and magnitude is a vector quantity. Right? So velocity is a vector quantity, speed is a scalar quantity. Right? Now, what is the magnitude of this velocity? 2 meters per second. 2 meters per second is the magnitude of the velocity. Is it changing? No, it's not changing. It's same. But what is changing is the direction. It has moved till here and then it turned. Therefore, any one of these, either magnitude or direction changes, the main physical quantity changes. Right? So this is very important example, whereas speed remains same but the velocity changes, though the magnitude is same. I can take one more example where object moves on a circular path. Let's say object moves on a circular path, okay, but the speed of that object, we shall mention 3 meters per second, just a number. And if it keeps 3 meters per second for every small intervals of time, for every small second throughout its path on a circular path, now we can say that speed is constant. This is the uniform speed. Right? Or we can say it's a constant speed. But can we say it a uniform velocity or a constant velocity? Is there any change in velocity? Now look at this point. When the vehicle, when the object moves here, what is its direction? Direction is towards this. When it comes front, it will be towards, so direction is changing. And throughout the circular path, the direction keeps changing. As I said, velocity has a direction as well as magnitude. So any one of these changes, the velocity changes, and therefore though the speed is same, velocity is not constant. Okay, this is very important. You can expect questions on these situations, right? And therefore as the direction changes, velocity also changes. Let's go for one more example here. Let us take example where the car moves in a straight line, right? And then I am going to make A and B as an initial and final position here, and I'll represent a velocity on the top of the line as well as time below. Please remember, I am representing velocity, not the speed. And how will you express velocity? Meter per second, and time is in second. And why not speed? Here speed and velocity will be same. Why? Because it is moving in a straight line. So let me have time on one below the line. So 1 second, 2 second, 3 second, 4 second, 5 second and 6 second, and at 1 second velocity is 2 meters per second. Now next second the car did not move fast, it remained 2 meters per second, and so on. Its odometer showed 2 meters per second. So everywhere it is same. Is there any acceleration? What is acceleration? In this situation, we say that there is no acceleration at all. Now then, what is acceleration? There is acceleration only when there is change in the velocity. Okay, so acceleration is change in velocity. I can write change in velocity per unit time, or in short you can say that acceleration is rate of change of velocity. Is there any change in velocity with time? No. Therefore, no acceleration. Now, in this case, let's say a vehicle has 2 meters per second and then it has gone to 3 meters per second, 5 meters per second, 6 meters per second at 4th second, and 5th second it is 7 meters per second. How much changed from here to here? 2 meters per second changed. How much is the change here? 1 meter per second changed. Again, how much change? 2 meters per second. Here again 1 meter per second, and then again 1 meter per second. There is a change. Sometimes it is 2 meters per second, sometimes it is 1 meter per second, but there is a change in velocity. And when there is a change in velocity, and then we say that the car has acceleration. So acceleration is defined as rate of change of velocity. Okay, so you can say rate of change means a time. And how will you express that? Acceleration is equal to change in velocity divided by time taken. Let's take these two time. Okay, between 1 second and 2 seconds. Right? So we shall calculate acceleration. So how much is the change in velocity here between 1 second and 2 seconds? 1 meter per second. So 1 meter per second is change in velocity divided by how much time it has taken to change that velocity? 1 second. So therefore 1 meter per second means divided by second. Correct? So this second will come down here, and then the earlier second is still there, 1 second. Okay, so this is there here, this one. And 1 meter per second means 1 meter divided by second. So finally, the answer will be 1 meter per second into second, second square. So here the acceleration is 1 meter per second square. So remember, SI unit of acceleration is meter per second square, and SI unit of speed and velocity is meter per second. So please keep the difference here. Now we shall see the acceleration between 2 seconds and 5 seconds. Right? What is change in velocity? I am doing here itself, or let me do here between 2 seconds and 3 seconds. So acceleration, I will represent A as acceleration, and change in velocity 3 meters per second to 5 meters per second. So you have to minus it. 5 minus 3 is 2 meters per second divided by how much time it has taken? Just 1 second. 1 second. So this becomes acceleration is equal to 2 meter per second per second. So it becomes 2 meter per second square. If you want to find out acceleration between any two time interval, for example 1 second and 2 seconds, it's orally you can easily found, because acceleration is change in velocity divided by time taken. So change in velocity is here 1 meter per second. 1 meter per second per second, which is equal to 1 meter per second square. Here it is how much? In 1 second. In 1 second, how much is the change in velocity? 5 minus 3, it is 2 meter per second change in velocity for 1 second. So 2 meter per second square is the acceleration. Again here acceleration is, it was 5 meter per second and this is 6 meter per second. So it is again 6 minus 5, 1 meter per second square. This is again for 1 second. And the same way here also it is 1 meter per second square. So the acceleration is equal to, you can write final velocity minus initial velocity divided by how much time it has taken. Time taken. Okay, if you give a symbol A is equal to, final velocity is generally given a symbol small v and initial velocity is small u and divided by t is the time taken. Please remember that. We will discuss regarding this in the future videos in detail. So you understood that in between every 2 seconds, in this case for example from here to here, between 2 seconds and 3 seconds, which is final velocity, 5 meter per second is the final velocity and initial velocity is 3 meter per second. So 5 minus 3 becomes 2 meter per second square is the acceleration. Now we'll go for one more situation where the velocity is, changing and therefore there is acceleration. But let us find out how it is changing. How much of velocity is changed here? 2 meter per second. How much from 1 second to 2 seconds? Again 2 meter per second change in velocity. Here how much it is changed? 2 meter per second. So everywhere the change is 2 meter per second. So velocity is changing. Okay. So therefore if you calculate acceleration here, acceleration becomes change in velocity 2 meter per second divided by 1 second becomes 2 meter per second square, and it will be same everywhere. Right? If you find out the acceleration at every point here, the acceleration will be equal to 2 meter per second square because change in velocity is same. Such acceleration is called uniform acceleration. What is that acceleration? Uniform acceleration. Right? So if the velocity changes in equal amount, remember, if velocity changes in equal amount, then the acceleration is uniform acceleration. Right? Now we will take both the examples together here. Look at this velocity 2 meter per second, 3 meter per second, 5 meter per second. Here suddenly 2 meter per second velocity changed. So again, right? So here only 1 meter per second changed, 1 meter per second changed. So if you compare these two, which is the uniform acceleration? In this case, change of velocity is constant. And how much it is? 2 meter per second. Therefore, such acceleration is uniform acceleration. So definition, if it is written, uniform acceleration is if a body has a uniform acceleration, if it travels in a straight line and its velocity increases by equal amounts in equal intervals of time. Okay, in equal intervals of time. Now in the next video we shall see about retardation. So in this video the time has already moved beyond 20 minutes, so we will see retardation. We'll take up the same situation in the next video and find out. So till then what you have studied is acceleration depends on velocity. And acceleration is given by the formula final velocity minus initial velocity divided by time. And acceleration has a SI unit meter per second square. Right? This is change in velocity, this is change in time. Okay, if velocity doesn't change, then there is no acceleration. right? So that much you just remember. Thank you very much.